Hello, my name is Mark Riddell. I'm a professor at Georgia Tech, and I am delighted to be here to talk to you a little bit about creativity and some of my work. I want to start by thanking the organizers. The NeurIPS workshop on creativity is the true gem of NeurIPS. It's the delight, and I'm always happy to be able to attend, and I'm especially happy to be able to kind of share some of my thoughts with you, and I look forward to being able to speak with you more interactively later on. So a little bit about myself. Once upon a time, many more years ago than I perhaps want to think about, I built an AI system that could generate stories. And for whatever strange reason, people gave me a PhD for that. Great. But ever since, I've been kind of fascinated by this question of what creativity is and how computers can manifest creativity. So I wrote my first kind of thoughts down on this in 2005, and ever since I've been building systems that try to do creative things, such as cinematic movie generators, story generation systems using machine learning, of course, game generators, and even last year I had a paper in this actual workshop on parody lyric generation, a system called Weird AI Yankovic. And to be honest, I only built the system just so I could make that pun of a name. Also, I've worked on providing computational theories of how creativity might manifest themselves in computer systems, such as how computer systems can think about blends of different things that it's never seen before, let's say with a horse with wings. And there's been some fascinating results that have shown that these computational creativity systems expand beyond just the creation of things, but can also help real practical problems like improving transfer learning or improving architecture search. Now, in the meantime, of course, there's been this massive explosion of interest and research in creative systems, and it's manifested itself in many different ways. And it's been a very exciting last few years for dealing with computational creativity. And so that kind of has brought forward all sorts of research questions that I think are really interesting and useful to look into. And I'd like to kind of touch on a few of these today. Questions such as, where does the creativity in a system lie? Does it lie with the algorithm, or does it lie with the person who initializes and gives the inputs to a system, or is it a hybrid of both of those things? If our system, we do deem it creative, what aspects of the algorithm are actually responsible for that creativity? Can we point to what is causing the system to be more creative than not? And if it is creative, what attributes should we expect to find in a creative system? And then, the big one is like, what the hell is creativity anyways? And I'd like to kind of look at all of these, but I'm going to start with the last one, this question of what is creativity? And so happy to share my thoughts here. The answer is I don't know. I don't have a good definition for creativity. I don't think anyone has a good definition for creativity, but that doesn't mean we can't make progress. But even though I don't really know if I can put creativity down in words, there are many things that I have come to find useful to think about when I'm thinking about creative systems. And I'd like to share these with you. Not because I think these are right, but it creates a discussion. It creates an opportunity for discussion about what we should and should not expect to see in our creative systems. And I'll kind of walk you through what I think some of these ideas mean. And how they've been useful in kind of crafting my research agenda and my work on creative systems. And I think we'll start with novelty. I think novelty is the one that is easiest to think about, that most of us think about. Novelty, of course, is difference from the past, either previous generation outputs or previous, the history of all previous artifacts of a certain type. But I don't think that novelty is necessarily the same as creativity. I think it's necessary but not sufficient. We do want to see novelty, but the easiest way to achieve novelty is by injecting randomness into our system and to the outputs. But of course, that comes with a danger. Too much novelty can result in perceptions of randomness. Basically, things become too random and they become less interesting to people. So while novelty is important, there needs to be some force, some factor that pushes back against novelty, that balances against novelty. And if I think there's one thing that really kind of balances against novelty, it's something that I call expectation. So expectation is just alignment of the outputs of a system with a human mental model. So the sense that we have some ability to expect, to understand things, and to find meaning in things. And one, there's multiple levels of expectation. There's multiple layers to this. The first is, maybe we need to make sure that any sort of output references somehow this idea of a shared mental model of semantic relationships. And I think a good way of demonstrating this is to look at the DALL-E system from OpenAI. And they have this great example of a baby daikon radish in a tutu walking a dog. And what you see with all these outputs is that, it kind of conforms to what we would expect if we were to build a mental model of, or a mental image of what a radish walking a dog would look like. Now there's some weirdness, so sometimes the leash is attached to a tutu, and I can't believe I'm talking about this, but this is where we are nowadays, right? We usually think about an arm should be holding the leash instead. So there are some errors here, but I think it generally conveys things that we would expect to see. Now, that is kind of the first layer, but then the second layer of expectation is that maybe what is interesting about creative outputs is to intentionally go on beyond that shared mental model, to challenge the mental model. So I look at this one here of the kind of the radish floating in space and walking the dog, and it says, to walk a dog, do you have to walk yourself, or can you float? Now, intentionality is key here. I think this was a kind of a random output, a random accident that happened to be interesting. So I think you also want to be able to kind of intentionally kind of create different interpretations. But what does this term intentionality mean? Let's focus on that. That seems to be important here. So intentionality, of course, means doing something with purpose, having a goal, right? So we can think about intentionality as given a particular goal, selecting and planning the elements that achieve that goal, possibly backtracking to find better ways of achieving a particular goal. But you know what? Maybe it's more than just finding a way to achieve a goal. Maybe the way how you achieve the goal is important. Can we not only achieve the goal, but find it in an unexpected but still understandable sort of way, which kind of blends in the notion of expectation and novelty into the process, bringing everything all together. And then I think what's really fascinating is expert human creators, they go through this reflective process where they look at what they're creating, and they often change their goals, and they end up trying to create something that they didn't initially sit down to do. And I think that's a fascinating thing that we don't know how to do with AI systems yet. And the last thing that I often think about is learning. So we think about creativity, we think about the skills, learning the skills to be creative or to do creative things. And when we look at humans, humans go through this process of learning the skills to create. And when humans do this, they often start with this idea of imitation, finding an image that they really like, and then trying to replicate it, or finding some music they like and trying to learn the chords, things like that. But then at some point, it's not sufficient just to imitate. We want to then kind of bring in our own ideas to say, well, what can I do that expresses myself? Based on the skills that I learned through imitation, can I push forward and outward away from the things I've seen before? And then eventually you get to the point where we start to say, well, what can we really do? Can we really start to challenge people's expectations and deviate and come up with kind of strange new things that are uniquely our own? And why I like to think about learning is because this matches up very interesting with the way that our AI systems have evolved. So I think a lot of our creative systems involve GANs or things with reconstruction error, where we're basically trying to recreate a data set. And there's error that makes it so we can't do that, but that ultimately results in interesting outputs. And then we start to realize that we can make our discriminators fancier. We can start to add kind of different goals or elements to our discriminators. We're starting to see some of this sort of work happening here. But then, like the true holy grail, I think, of generative systems is being able to intentionally deviate from these expectations. And I think we don't even have a theory of how we can go about doing that. But I think this is really kind of a fascinating trajectory that we're on. Okay, so if we kind of believe that those are the sorts of things we would expect to see in a creative system, well, how do we know it's there? Can we point to where it is in our system that the creativity lies? And I found this a mental exercise to be very useful in the last few years of what I call the creativity audit, which is to kind of try to think about what is causing our outputs to be interesting. And there's many places we can find creativity in our systems. I think one place is in the model itself in a machine learning system. But we often find that what is creative is actually error. So here's a portrait, right? The portrait is kind of interesting to look at, but it's because it went wrong. There's something that the system has not learned about portraits. Now, because expectation, I think, is one of the factors that we should be concerned about, we can also think about generalization and the ability for a model to generalize as a factor in the creativity as well. So in the case of a hybrid animal that an AI system's never seen, being able to put the pieces together in a way that we think kind of makes sense. Like the neck is in just about the right place here on this hybrid turtle giraffe thing. We can find creativity in the algorithm as well. It might be through sampling, which basically means injecting randomness to get novelty. We might think about it as planning or search to say, here's how we get purpose into the system, intentionality. And we can probably also find it in the loss reward function, which ultimately is a guiding factor for some sort of sampling or search-based process. Now, where we tend to also find creativity is not in the algorithm itself, but in the problem specification. So when we do domain transfer or style transfer or gap infilling in story generation, it's often about what good inputs to the system, right? So this is one of my favorite style transfer images ever, but I know it's only good because the choice of the original source image and the choice of the style image were well chosen to go together. And if we'd made any of those choices differently, we might have gotten a different image, which may or may not have worked a lot. So humans ourselves actually go through a lot of the search before we even kind of, specify the inputs to our system. So I'm going to shift topics a little bit here and talk a little bit my own work, and not just because I want to talk about my own work, because I kind of want to talk about how the creativity audits and the kind of the factors of creativity we talked about have really kind of informed my development of a research agenda to see how these sorts of ideas kind of play out in actual research. Okay, so, early on, as I mentioned before, we started building story generation systems many years ago. We started with symbolic search and theorem proving, things like that, the idea that we can build a causal graph and then generate a story from that causal graph. And I think this was great work, but I also was a little bit unsatisfied by it because to make the system work, we had to do a lot of domain knowledge engineering. We had to specify all these kind of semantic information about how the world worked, from domain knowledge, outcomes, even the initial state. And I always kind of thought, like, if you get this right, you get a good story. If you get this wrong, you get a bad story. So who's responsible for the creativity? Is it me as a good domain knowledge engineer? Or is there something about the algorithm making use of this information that is responsible for the creativity? Or is it a combination of both? So what I realized is I had to get kind of the human out of the domain knowledge specification thing. So we switched to a new technique in which we tried to learn domain knowledge from a crowd. So we'd ask the crowd for a bunch of exemplars of doing things. We try to learn a model and then build a story kind of based on what we learned and put into the model from that. Now, in the last few years, we've ended up with some very powerful large language models like GPT and things like that, and which are also quite capable of generating stories if you prompt them correctly. So here's a prompt that one of my PhD students, Laura Martin, former PhD students now, came up with. Right? She just said, "Hungry dog licked her lips and watched her owner eat," and let's just kind of see what happens. And now I think this is actually not a bad kind of chunk of text here, but it does kind of highlight some interesting things. The first is that this neural net is thinking that this is a pretty good story because it matches its probabilistic sampling. It says, well, I should talk about blood because that goes with dogs and jaws. And once I talk about blood and teeth, well, maybe wolves are a very reasonable thing to talk about as well. Now, I think when a human reads this, we're trying to track what's going on in this story. We're saying, all right, who's the character? There's a dog. The dog has teeth, okay? The dog has an owner. The owner's near Jack. Jack seems to be angry, so these seem to be facts about what's going on inside the story world. And at some point, we say, wait a minute. How do wolves fit into my mental model of what's going on here? I'm a little bit confused. Is the dog a wolf? Is the wolf a dog? There's something that's not quite right. So I think there's a discrepancy between what neural nets are trying to do and how humans try to read. And I think we need to do something about that disconnect here. So if we kind of pull this apart and we look at, how did this story get generated, right? We take a previous context, we run it through our language model, whatever happens to be, we get a whole bunch of logits out, we sample from those logits, and then this becomes the next part of our story. Well, if this is insufficient, maybe we should also try to guess what the human is referring, the reader is inferring about the true state of the world, as if there is a true state of the world underneath, right? And then if our sampler can also kind of look at this and say, well, here is the new set of inferences that a human would make if we chose this particular sentence, then we can look for things that are weird or discrepancies or opportunities, right? And maybe this is not the right sentence because it creates a discrepancy in the reader's mental model. So maybe we should reject that, go back to the sampler and try something else. And this is what we've been trying to do. We refer to this as inferring the reader. And this is kind of a way we've been trying to combat novelty or randomness with expectation. There's many different ways we can infer what the reader is going to try to do. We can look at linguistics and what linguistics tell us about what people can infer from the way verbs are used in particular sentences. So syntax begets semantics, for example. And to kind of give you an example of what we can do with these sorts of reader models, we can we can look at not just what the story is, but what the system rejected, right? So the first attempt at generating the story, the system tried to have a character use an object that they didn't have, and you can't use an object you don't have. So that was rejected, and we chose a different path. And then later on, the language model tried to say a location is able to escape, but locations can't move, right? We don't usually expect that, so we reject that. So we can look at the rejections and we can say, this maybe not be a great story, but it could have been a whole lot worse. There are other ways of inferring the reader that we've looked at. So we can use neural networks that try to guess what the common sense inferences are about when people kind of look at particular sentences. And here's an example of how that can be used to kind of create coherence. So the green ones are the outputs from our system, and the red one is from a standard language model. And if you look at the red one, right, so this is a very incoherent story, right? So two characters going on a date, Bob threatens, and then they all get awarded for having fun. Like this, there's some very toxic and unfortunate and incoherent things going on there. Pushing beyond just expectation, we might say, well, maybe we want intentionality. We want goals, right? Suppose I don't just give an input prompt, but I give a prompt and a goal. Can we build a system that learns to kind of plan to get that goal? So we're used to thinking about generating stories by taking a context, putting it through a language model, sampling from those continuations, picking continuation and adding it to the context. But what we're trying to do here is to say, well, let's figure out how the continuation affects the user's mental model, and then have another model, a reinforcement learning model, that picks the best continuation, the best advance of the mental model. And then we could do fun things like build these kind of training reinforcement learning loops where the models kind of self-supervise each other. So again, all that was not to kind of give you details about my own particular research, but kind of look at how these ideas of creativity, novelty, and expectation have guided kind of the progress in building a research agenda for myself. So a lot of my work has been looking at expectation. So language models, they do have some implicit understanding of semantics. They do a reasonable job, but they get a lot of unintentional novelty here, right? So the reader model, the whole point was to come up with some sort of shared mental model that we understand with explicit semantic relationships to try to balance randomness with a greater sense of expectation, so people feel more coherent, more meaning comes out of the stories. And then using the reinforcement learning to kind of push up back against intentionality to say, well, can we actually kind of think harder about which things we do pick and which things we do reject as we go forward? And the idea is all this can set the stage to look at deeper, more sophisticated levels of expectation and intentionality, going forward as we look at future work. Okay, so in addition to all of that, in the long time I've spent thinking about creativity, I've also been very interested in seeing how we can track our progress. Are we actually getting more creative systems? Are we building more creative systems? Do we understand creativity better? And to do that, I started looking at how we evaluate our creativity systems, and I developed something called the Lovelace 2.0 test. Now, this is named after Ada Lovelace, who is the first person that I know of that really philosophized or thought about or wrote about creativity in intelligent machines. So in 1843, she said the analytic engine, which by the way hadn't even been built yet, has no pretensions to originate anything. It can do whatever we know to order it to perform. And I think this is actually still true, but I think our understanding of what it means to order a system to do something has become much more sophisticated when we consider machine learning and the ability to learn to do things that we order it to do. So I set about kind of thinking about the problem of evaluating creative systems because in 2014, 2015, a lot of researchers were asked to re-envision the Turing test. And I thought, well, creativity seems to be a particularly highly associated with intelligence. So can we ask whether an AI system can comprehend a request from a human to perform a particular task that requires creativity? And I was thinking in particular about blending concepts, right? So what happens when we want to do something that blends a bunch of concepts, like this bunny riding a spider cat with an alligator tail, right? That's actually kind of 3 or 4 blends going on in there. And I think semantically we can see how those elements appear. This is a drawing from my, at the time, 7-year-old son. Okay, this was about expectation, right? And so maybe intelligence means demonstrating understanding by being able to create what was asked for. So now it turned out someone built something called the Lovelace Test before me, some folks who are actually involved in the Watson project. But, I wasn't particularly happy with their system. They basically said if a creator of an algorithm can't explain the algorithm's output, then the system must be creative. I think that's a pretty high bar for deciding what is creative. And I also think that there shouldn't just be a particular bar for creativity, right? We should be looking at kind of relative improvements to creativity over time. So here was my attempt, right? We call it the Lovelace 2 test, which is a kind of an update. Right, so we have this idea that there's a human evaluator. This evaluator chooses a set of criteria, something that they want to ask for to be created, and it should be expressible in human language. Given that criteria, we take an algorithm and we let the algorithm try to create an output artifact based on that input, and the human then gets to decide, the evaluator gets to decide whether that output artifact meets the criteria they gave it in the first place. And they can decide, yes, it does, no, it doesn't, right? Now, we also need to accept the fact that we don't want the human asking things that are impossible. So we also have a referee or a judge who is able to say, those criteria are probably even too hard for humans, so we shouldn't be asking them of computer systems as well. So the way the Lovelace kind of plays out is we start with one criterion that a human judge gives, like let's say I want a picture of a penguin. Right? If the system succeeds, then we add new criterion, forcing composition and blending. So let's say a penguin on Mars. And then we keep doing this. We keep adding criteria over and over again, and we end up with something called the creativity index, which is basically how many rounds are passed, how many additional criteria do we add before the system fails to meet the expectations of the judge. And then one of the important things here is that there's no threshold. We don't say you are creative or you're not creative. We basically just count the number of rounds, how long the system can go before it eventually says, I can no longer accommodate what you're asking for. And this allows us to track progress over the years, year-over-year progress of our computer systems. And I'll be honest, in 2014, 2015, when I was coming up with this, I thought this was going to be a thought experiment. And of course, I'm clever enough. This will be a thought experiment and no one will ever want to run it. Within a first year, we started seeing pictures, images, papers of, creative outputs, a blobby red thing in the sky trying to generate a stop sign that flies. Right, then more and more things. This is from Rudgway, which we've seen in this workshop series before. And then in the last year, DALL-E and GANs plus clip-guided GANs and things like that have just kind of like created many more sophisticated kind of scenarios. And you can sort of see, the elements play out. And so, okay, so let's try it. Let's just say, where are we now? What is the creativity index of 2021? Okay, so I did this. I got a VQ can, Flip got a VQ can, and I just started giving inputs to it. And I asked, first thing was a penguin. Okay, so this is not a great penguin, right? We might have stopped here and said, all right, that's a pretty weird penguin, but maybe it's penguin enough, and I'm willing to be generous, and let's go on, right? So let's say we pass, right? What about a penguin on Mars? Okay, that's actually not too bad, right? Definitely Mars-like, definitely penguin-like sorts of things on here. One of those blobs has got to be a penguin, right? A penguin on a Mars wearing a spacesuit, and whether you wear a tie on a spacesuit, I don't know, but I'm gonna willing to accept that that's kind of helmet-like and spacesuit-like. So we're good there. Things are starting to get a little bit blobby here. Let's go on. What about a penguin on Mars wearing a spacesuit walking a dog? And our spacesuit's starting to fall apart here, but maybe that's a dog-like sort of blob next to it, and maybe it's a walking situation. Maybe let's go. Let's do one more, right? A penguin walking a dog, a robot dog. Okay, dog definitely got more robot. I think the penguin there's still penguins in spacesuits. Maybe we're still good. How about a penguin on Mars wearing a spacesuit walking a robot dog next to Santa Claus? All right, nailed the Santa Claus. Penguin has become a banana. All right, maybe at this point we're going to give up. Anyways, the point is, we're hitting creativity indexes of 3, maybe 4 if we're generous. But that's bad. That's pretty good. Like considering it just a few years ago, I thought maybe like we'd be lucky to get 1 or 2. Okay, and just to make sure that we're not asking the AI system to do something impossible, I also tried to draw a penguin in a spacesuit on a Mars wearing a dog, and I also experimented on my 7-year-old son and asked the same thing. So I think this is not an unreasonable test that we just did. It's not scientific at all. Since the Lovelace test was never meant to be run, there's a lot of details that we haven't worked out, like who the evaluators are, whether the evaluator should be lenient, whether the decision should be binary, and so on and so forth. So I've listed some things here, but I'm not going to go through them all because I'm getting pretty short on time, and I basically just going to step back and kind of return to some of the big themes and big motivations of this talk, which is creativity is cool. Why should we study creativity at all? Well, obviously one reason is like we get to make cool stuff. Not only that, we get to make things that make cool stuff, so that's doubly cool, right? But you know what? I think creativity is fundamental to the human experience. So if we were going to build AI systems that we want to consider as intelligent, whether we're interested in AGI or not, people are going to ask, well, if it's not creative, have we really kind of achieved anything important here? On a more practical note, we're probably very interested in building assistive agents that can match human creativity, because they can't be helpful if they can't keep up with human creativity. And if they're not able to make their own creative leaps and intuitions, are they really going to be useful to us in problem solving? And then finally, I think, there's a lot of interest, and I think this is a great thing to look at, supporting human creativity with intelligent tools. The fact that I may not be a very good artist, but I can ask for a picture of the analytic engine in a steampunk theme and actually get something out. And this is a picture I didn't expect, but I actually kind of like it. So I think that this is a success. And it was a tool that helped me express my creative thoughts. And I think that's a very powerful thing for human society. So with that, I'm going to stop. I'd like to thank you for listening. I look forward to talking to you more interactively online, wherever it happens to be. There's a lot of people's thinking went into this. I'd like to thank all of them. And I look forward to the rest of the workshop. Thank you very much. Have a good one.